Hello everyone, welcome back to my YouTube channel. Myself Pallavi M. Currently, I'm studying in Sri Venkateswara College of Engineering from first year ECE branch. Today's topic is radius of curvature in Cartesian curve. Let's see introduction of radius of curvature of Cartesian curve. Introduction to radius of curvature in Cartesian curves. The radius of curvature of a curve at a point is a measure of how tightly the curve bends at the point. It is the radius of the circle that bends approximates the curve at the point. The smaller the radius of curvature, the sharper of the bend. For a Cartesian curve defined by the equation y equal to f of x, the radius of the curvature at a point y xy is given by the formula rho equal to 1 plus y1 square whole to the power of 3 by 2 divided by y2, where y1 and y2 are the first and second derivatives of the f of x, respectively. Evaluate at the point xy. Rho is the radius of curvature. Expression for the radius curvature for a Cartesian curve. Let y equal to f of x be the equation of the Cartesian curve, and AP points. Let P of xy be a point on the curve such that AP equal to S and xi be an angle made be an tangent at a point with x-axis shown in the figure. We know that tan xi equal to dy by dx. Equation number 1. Differentiate with respect to s. It becomes secant square xi d xi by ds equal to d by ds into dy by ds. Secant square xi d xi by ds equal to d by dx into dy by dx into dx by ds. By the definition, cos xi equal to dx by ds, 1 by rho equal to dxi by dx. Secant xi dxi by ds equal to 1 by rho equal to d by dx into dy by dx equal to d square y divided by dx square, and dx by ds equal to cos xi. Finally, it becomes secant square xi 1 by rho equal to d square y divided by dx square into cos xi. 1 by rho shifted to LHS, secant square xi equal to rho into d square y divided by dx square, and rho shifted to RHS, and secant square xi shifted to LHS. It becomes rho equal to secant cube xi divided by d square y divided by dx square. Rho equal to secant square z whole to the power of 3 by 2 divided by d square y divided by dx square, and secant square xi equal to 1 plus tan square xi. By the formula of it becomes 1 plus tan square xi whole to the power of 3 by 2 divided by d square y by dx square. From the first equation number 1, tan square xi becomes dy by dx whole square. Rho equals to 1 plus dy by dx whole square whole to the power of 3 by 2 divided by d square y divided by dx square. Consider dy by dx equal to y1, d square y divided by dx square equal to y2. Finally, the radius of curvature of a Cartesian curve formula becomes rho equal to 1 plus y1 whole square whole to the power of 3 by 2 divided by y2. Sometimes y1 at some point on the curve becomes infinity. In such case, we can't apply the formula rho equal to 1 plus y1 square whole to the power of 3 by 2 divided by y2. In such case, we have to use the formula alternate form, that is rho equal to 1 plus x1 square whole to the power of 3 by 2 divided by x2, where x1 equal to dx by dy, x2 equal to d square x divided by dy square. Some problems on radius curvature of Cartesian curve. First problem is show that radius of curvature for a catenary of uniform strength y equal to a log secant x by a is a secant x by a. By using the formula rho equal to 1 plus y1 square all to the power of 3 by 2 divided by y2. Um, y equal to a log secant x by a, differentiate with respect to x, differentiation of y equal to dy by dx, and differentiation of a log secant x by a equal to a in 1 by secant x by a, and differentiation of secant x by a equal to secant x by a dot into tan x by a, and differentiation of x by a equal to 1 by a. Secant x by a, secant x by a cancelled, a cancelled. Consider dy by dx equal to y1. Remaining is tan x by a, therefore y1 equal to tan x by a. Y1 is differentiate with respect to x, becomes y2 equal to secant square x by a into 1 by a. Apply y1 and y2 to the formula. Rho equal to 1 plus tan square x by a whole to the power of 3 by 2 divided by secant square x by 2 divided by a. By the formula 1 plus tan square x by a becomes secant square x by a. Therefore, rho equal to a into secant square x by a whole to the power of 3 by 2 divided by secant square x by a. 2 cancelled. Rho equal to a into secant cube x by a divided by secant square x by a. The secant square x by a, secant square x by a cancelled. Therefore, rho equal to a secant x by a. Second problem, y equal to c cos h x by c. Prove that y square divided by c by using the formula rho equal to 1 plus y1 square all to the power of 3 by 2 divided by y2. Y equal to c cos h x by c. Equation number 1. Differentiate with respect to x. Y1 equal to c sin h x by c into 1 by c. C cancel. Y1 becomes sin h x by c. Y1 differentiate with respect to x, therefore y2 equal to cos h x by c into 1 by c. Apply y1 and y2 to the formula rho equal to 1 plus sin h x by c square all to the power of 3 by 2 divided by cos h x by c divided by c. By the formula 1 plus sin h x by c square becomes cos square h x by c, and denominator c shifted to numerator. Therefore, rho equal to c into cos square h x by c all to the power of 3 by 2 divided by cos h x by c. Um, Square cancel. Rho equal to c into cos cube h x by c divided by cos h x by c. Cos h x by c, cos h x by c cancelled. Therefore, rho equal to c into cos square h x by c. This is the equation number 2. Equation number 1 becomes cos h x by c equal to y by c. Equation number 2, cos square h x by c replaced by y by c whole square. Therefore, rho equal to c into y square divided by c square. C cancelled. Therefore, rho equal to y square divided by c. This is about radius curvature of Cartesian curve. Thank you for watching to all.